Hello, this movie is for Learning Target 4, Properties of Rectangles, Rhombuses, and Squares. Please remember that we did a warm-up where you cut out a rhombus in paper, and we learned a lot of properties about a rhombus. So remember that as we go through this. A rhombus is a parallelogram with 4 congruent sides. This is a definition for a rhombus. A rectangle is a parallelogram with 4 right angles. Definition of rectangle. And a square is both a rhombus and rectangle in that it has 4 congruent sides and 4 right angles. So pause the movie, put squares, rectangles, and rhombuses in this Venn diagram, and then play, and we'll go over it. All right, what we know is that a rhombus has 4 congruent angles. Sides. And a rectangle has 4 congruent angles. They're all 90. And what we know is that a square has both. Both of these conditions are holding true in a square. Therefore, we say that a square is both a rectangle and a rhombus. Now, also keep in mind, which is sort of bizarre, is that all of these are a type of parallelogram. So within the parallelogram family, we have these specific types: rhombus, rectangles, and squares. Let's look at a stained glass window. This symbol means parallelogram, so it's as if you're given that it is a parallelogram, a rhombus, rectangle, or square. So in looking at A, B, C, D, I enlarged it over here so you can see it. We've got A, B, C, D. We've only been given that B is a right angle. So what we know is that in a parallelogram, opposite angles are congruent. So if B is 90, then D is 90. We also know that consecutive angles are supplementary. So if D is 90, then C has to be 90 because they add up to be 180. Same thing for A. So that we know about A, B, C, D is that they all have 90-degree angles. Therefore, we say that this is a rectangle because there are 4 right angles. Now, you might say, could we say it's a square? We're not able to prove anything about the sides, so no, we cannot say it's a square. Down here is parallelogram EFGH, a rhombus, rectangle, or square. Where EFGH is this shape here. We're only given these 2 sides congruent. And so what I know with the parallelogram is opposite sides are congruent. So if EF has 1 slash, so does HG. If EH has 1 slash, so does FG. What this does is it creates all 4 sides being congruent. So this is a rhombus. All 4 sides are congruent. Okay, let's go to the next page. We have a couple more theorems. This says, if a parallelogram is a rhombus, then diagonals are perpendicular, and we saw that when we did the cutout. That fold ended up showing us the diagonals, and they were perpendicular. If a parallelogram is a rhombus, then diagonals bisect a pair of opposite angles. So this diagonal is bisecting these angles, and this diagonal is bisecting these angles. And we get that all 4 of those are congruent because a rhombus is a parallelogram. Parallelogram has opposite angles congruent. And so if in a rhombus, the diagonal is bisecting that angle, then we get that all 4 of those are congruent. What are the measures of the numbered angles in this rhombus? So we're given it's a rhombus. We got to get the measure of angle 1, 2, 3, and 4. Pause the movie, try this on your own, and then press play when you are finished. Okay, now that you finished this, we've got 58 degrees here. This one is also 58 degrees because it's a rhombus. Diagonals bisect the angles. This is a parallelogram. A rhombus is a type of parallelogram. So these are both 58 as well. So we get 2 and 3 are 58 degrees. Now, if 3 is 58, 2 is 58, we get 1, which is showing the diagonals and how they intersect. I know in a rhombus that they're all 90-degree angles. So angle 1 is 90 degrees. And if 1 is 90, 3 is 58. To get 4, we do 180 minus 58 minus 90 because they will add up to be angles of a triangle. So 4 ends up being 32 degrees because of that triangle. Pause the movie, try number 3 on your own, and press play when you are finished finding each of the measures of the angles. All right, now that you finished this problem, we do have that it's a rhombus, so we know all the properties of a rhombus hold true. And one of them is that a diagonal bisects opposite angles. That tells me that 1, 2, 3, and 4 are all going to be congruent. And so if Q is 104, and I let 1 be x as well as 3, I know that 104 plus x will equal 180, because that is a triangle, and triangles add up to be 180. So I'm going to solve this. And I get 38. So that tells me that all of these angles are 38 degrees because it's a rhombus. This theorem says if a parallelogram is a rectangle, then diagonals are congruent. So if I connect A to C, D to B, the diagonals, I get congruent diagonals. Now notice, in a parallelogram, diagonals bisect each other, but a rectangle is a type of parallelogram. So diagonals are still bisecting each other. It's just they're also the same length. So we can get that all 4 of those segments are congruent, only in a rectangle. Let's look at 4. Pause the movie, try this on your own, press play when you are finished. So we're given SF, which is a diagonal, and that's 2x plus 15. And that is going to be equal to the other diagonal, which is RB, 5x minus 12. And we're going to solve this. And we add 12, divide by 3, we get 9. So when x is 9, my diagonals will be congruent. It says, what is the length of the diagonal? So to get SF, we got to plug it back in. 2 times 9 plus 15, and we get 33. Now, a great way to double check yourself is to find RB, and that better be 33 as well. We got 5 times 9 minus 12, and we get 33. Excellent. Pause the movie, try 5A and B on your own, and then press play when you are finished. All right, in this diagram, we've got the 2 diagonals. We've got LN and we've got MO. We can set those equal to each other because a rectangle has diagonals congruent. So I solved this guy. Now I got x is 15. We want to find the length of the diagonals. So I'm going to do for LN 4 times 15 minus 17. So LN is equal to 43. And then I can also double check myself by doing MO, 2 times 15 plus 13. And that also gives me 43. So I know the length of my diagonal is 43. Now it's saying here, what type of triangle is PMN? So if I'm looking at PMN, that's here. I know a couple things about the diagonals. A rectangle is a type of parallelogram, so diagonals bisect each other, but because it's a rectangle, diagonals are congruent. Therefore, all 4 of those lengths are equal to each other, making triangle PMN having 2 side lengths congruent. That is an isosceles triangle. And it's not based on looks, it's based on properties. that's the end of this movie. Thanks for watching.